right, ladies and gentlemen, it's time to do the exact same thing we did last week in a slightly different way. That's right. This week, we're going to be using data in near real time from a camera feed to predict the number of people that are walking in front of that camera. But we're going to do it with machine learning models designed for discrete classification. Unlike last week, where our goal was to predict the exact number of people that were walking in front of the camera, this week we are simply going to be predicting a binary. That is it a busy minute or is it not a busy minute? Let's go ahead and get started. So first and foremost, you'll see this has been copy and pasted from last week's lab. This is identical. Nothing has changed here. This is the response or the request to the server to retrieve the real-time information. So go ahead and just copy and paste this from last week's lab if you so desire. The first thing that we'll be doing with that will be a slight deviation from the lab. So first, let's go ahead and copy in our functions. So these are our imports rather. So here we have pandas, seaborn, matplotlib, and numpy, the same as we did last week. The first thing that we're actually going to do that's a little bit different here is how we define our data set. So you'll remember the full data set here. So if we were to just print out our data set, so you'll remember this is the full data set. So we have the convolutional neural network parameters. This is just the, this is how many vertical lines there are in the image, whatever the case might be, number of females, image bright. Last time we were predicting the absolute value of person count. And this week we'll be predicting just the, was it busy or not. What we're going to do first is we're going to actually do this. So we're going to create this line of code, which is going to drop a lot of this data. So last week we used all of these columns of data in our regression models. This week we're only going to use 2 columns of data. Specifically, you'll remember CNN10 was a very, very important variable for the regression models. It had a lot of explanatory capability. So we're going to keep CNN10, and we're also going to keep image brightness, so how bright the image was. The reason we'll only be keeping 2 of our variables is simple. It's so the algorithms and their performance are easier to understand. In practice, you would want to use all of this data to build your predictive algorithms. For this exercise, we're only going to be using 2 columns because, quite frankly, the human mind can understand 2-dimensional space a lot better than 13-dimensional space. The next thing we're going to do is, let's go ahead and create our y variable. So our y variable is going to be created in a slightly different way than before. First, let's define a continuous version of y. So we'll do this. So this is the same thing we did before. We're simply removing person count from the data frame and saving it as y continuous. But we are going to do one more step here, which is define y like this. So what this will do is it will define y as either 1 or 0, depending on if it's greater than 30. So what we'll be doing here in practice, and we'll go ahead and print this out to illustrate. What we're going to be doing here is we're going to be saying, okay, if it's a 1, that means it was busy. We saw at least 30 people in the preceding minute, and so we're going to be calling that minute a busy minute. If we saw 0 people, we're going to say it is not a busy minute. And that is ultimately what we'll be trying to predict. So we'll be using the 2 time periods, the September 1st and September 2nd, to calibrate our model. And then we'll be predicting to September 3rd in near real time. The last thing that we'll need to do, first let's go ahead and save our x variables, and then let's do our standardizations. So this is the same exact standardization routine we employed last week. I'm just going to copy and paste this here. Make sure you do the same, because we'll be using this x scaled for most of our models. Run this. All right, so now we have our data loaded in. First, what we want to do is just kind of make a plot of our data. Every single point on this plot is going to be a minute of our days. First, let's just create some colors. So I'm going to say colors red and blue. And these will be the colors that we use to distinguish between busy minutes and not busy minutes. Let's define our figure. Okay, so let's go ahead and run through what this code did. So first we have these colors. So we have the blue and red dots of when there were busy times and when there were not busy times. Then we have the figure we're defining. Fig size is how big it will be, so an 8 by 8. plt.scatter. So we have the first thing is what our x-axis will be. So in this case, image brightness. The second one is our y-axis. So you'll see image brightness here, convolutional neural networks, or image brightness on the x-axis, convolutional neural networks on the y-axis. Then we have the C value. So this is what are we going to use to color the dots? That's what the C is, and the Y is literally these Y values that we calculated up here. So this is the binary 1 or 0. That's what's going to determine if the dots are red or blue. Label high foot traffic, so that is just the label for the legend, and then CMAP is the colors that we'll actually be picking for. We did red and blue in this case. Plot grid true gives us a grid, plot legend gives us a legend, and then X and Y labels. So the resultant figure is this. So this is a figure that shows us every single minute in our data set. So you'll recall there are about 2,800 minutes in the 2-day period we're using for calibration. And essentially what we want to do is we want to build a model that can distinguish these red dots from these blue dots. We want to be able to say with confidence a minute is busy or a minute is not busy based on image brightness and the values from the convolutional neural network. So every single model we employ is going to be attempting to subdivide this space in different ways and calling some areas of this space blue and some red. A very simple model might be simply draw a line at values from convolutional neural network feature at about 30. If you drew a perfectly horizontal line here, you would get everything above it right. Everything up here blue, and you would get everything down here mixed, right? Let's call everything below 30 is red, everything above 30 is blue. In that case, every single blue dot down here would be wrong, but every single blue dot up here would be right. So all of the models are trying to figure out clever ways to divide this space to minimize the number of blue dots that we're getting wrong and maximize the number of blue dots we're getting right, and the same thing for the red. In the next video, we'll begin to explore that through all of the different classification approaches we'll be examining in this lab.